So this is an example where we're going to graph a line whose equation is given to us in standard form. And the strategy we're going to use to do it is, well, we have a couple options for how to do it. The one I want to focus on, because this is where the question comes in, is let's find the x-intercept and let's find the y-intercept of this line, and then just plot those 2 points on the graph. And Euclidean geometry being what it is, if we have 2 different points, then there is only one line that we can draw that connects those 2 points. So if we draw those 2 points on our graph and then just connect those 2 dots, we'll be done. The second option might be the one that Philip has in mind when he asks the question, which is, well, where does y equals mx plus b come into the conversation? Because if you've had exposure to algebra in your past and you remember linear equations, you ended up using this y equals mx plus b template a lot in the process of determining equations for lines. And we will have the occasion to use y equals mx plus b, but it's not always necessary. We can do it in this example if we want to, but what I want to do is present 2 different ways, one of which uses y equals mx plus b, and the other which avoids it. So in the first option, what we'll do is first find the x-intercept and y-intercept. And to find the y-intercept of a line, and this, again, sounds a little counterintuitive, and I'll talk about why that is in a second. To find the y-intercept, what we need to do is set the value of x equal to 0. Similarly, to find the x-intercept of a line, we need to set the y-coordinate equal to 0. So let's just really briefly talk about why that's the case. If I pick a point that's on the x-axis, let's say this point right here is on the x-axis, what are its coordinates? Well, the x-coordinate comes first in the Cartesian coordinate system, so we'll write the coordinates of that point as 4, 0. Okay, well, let's pick another point in the x-axis, maybe over here. Coordinates of this point, -7, 0. This point right here, -2, 0. 1, 0. So I'm just sort of labeling a few points on the x-axis. And I'm asking the question, what do all these points have in common? Well, they all have different x values, right? 4, 1, -2, and -7. So the x values are all different. But the value of the y-coordinate is all the same. Namely, the y-coordinates of all these points, which belong to the x-axis, are all 0. And in particular, they're all the same as one another. So this is why, if I'm trying to find the x-intercept for any equation at all, in particular it works for a line, but it also works for any equation we're trying to graph. To find the x-intercept, I'm going to be specifying a value for y. Namely, I'm going to be asking, where does this equation cross the set of all points whose y-coordinates are all equal to 0? And if the y-coordinates are all equal to 0, that means that we live on the x-axis. And the x-axis happens to be a horizontal line. So, for example, if I have another horizontal line that I want to talk about, maybe I draw a horizontal line right here. If I want to know what an equation for that horizontal line might be, I might do the same thing. I might pick a few points on it and label them. So here's a point on this line, 4, 6. Here's a point, 1, 6. I could label some points back here, -7, 6. And so forth. And what you notice, again, is that all of the x values along this horizontal line are different, but all of the y values along this horizontal line are the same. Namely, this particular horizontal line is characterized by the fact that all of the y-coordinates along this line are equal to 6. So to just kind of summarize what we're talking about here, any horizontal line that we want an equation for is going to have an equation that has the form y equals some constant. Another way to think about that is if our equation has only a y in it and not an x in it, that means x gets to be whatever it wants to be. And as x runs around being whatever it wants to be, it moves to the left and it moves to the right, and therefore traces out a horizontal line because the value of y never changes. So we can move to the left, we can move to the right along this line because we're not specifying any value for x, but we can't move any up or down because our y value is held as a constant. And the same thing is true if we're talking about the y-axis specifically or a vertical line more generally. That if I pick some points on the y-axis and I ask about them, what are their coordinates? I'm going to come up with coordinates that look like -5, 0, 0, -5. 0, 2, 0, 7. And again, here are a set of points where all of the y values are different, but all of the x values remain the same. And so along the y-axis, we can specify that the value of x remain constant, because that means that we don't move to the left and we don't move to the right at all, but that y gets to do whatever it wants to do. Mathematicians would call it a free variable. Its value gets to be whatever it needs to be, and it just ranges from minus infinity to infinity. And in more generality, vertical lines do the same thing that the y-axis does, which means they have equations that don't involve the y variable whatsoever. So just a quick rule of thumb in general. If you're looking for an equation for a horizontal line, your equation will not have an x in it. It will only have a y. If you want an equation for a vertical line, your equation will only have an x in it and will not have a y whatsoever. So it's a little counterintuitive, because we tend to associate the letter x, the variable x, with something horizontal, and the letter y with something vertical. And that's true if we're thinking about the locating coordinates in the Cartesian plane. But when we specify an equation for a line, what we're really doing is we're not specifying what coordinates it may have, but we're specifying what requirement we're putting on top of those coordinates, is another way to think about it. And if I require that y remain constant, again, it means that I'm not moving up or down at all on my line in the Cartesian plane, but I can only move to the left or the right, making that equation horizontal. So let me take a minute and just go back to where we were in laying out our strategy.